Okay, so now let's do the next part of this. So let's consider these three matrices, right? So here's the homogeneous systems, right? So here's the A matrix, the B, and the C. Okay, so now we know that the solution set, right, for all three of these is going to be the same, right? That's from a previous theorem that we talked about. Okay, so we know from that previous theorem that the set of solutions to this system is going to be the same as the solution set of both of these systems. Okay. And now we're going to look at that final row, okay, that we're talking about, right? So because we said, okay, they're going to have the same for the smaller matrix, right? So the n minus 1, they're all going to be the same. So where they're going to be different is that final column. Okay, so let's take a closer look at that. Okay, so now with B and C different only in column n, so again we're gonna have to figure out which row, right? So they're gonna be different in column n, but let's assume that the difference happens in row I. Okay, let's just say in row I, that's where the difference happens in the last column. Okay, so now, if we subtract row I of this system from row I in this system, what are we going to get? Well, if they're all the same, right? So if they're all the same everywhere else except in that final column, well, everything else is going to drop out. And what are we going to get? We're going to get, so we're going to take the ith row, whatever the ith row is, right? And so what we're going to get is we're going to get B sub I n x sub n. Oh, hold on a second. C sub I n x sub n minus B sub I n x sub n, right? Equal to 0. And so we can simplify this and we can get C sub I n minus B sub I n quantity times x sub n equal to 0, right? So that's what will happen. Now, we can use the zero product principle. It's obvious that we have a problem here because we've already assumed that the coefficients are not equal, right? So these two coefficients are not equal, so that means x sub n has to be 0. Well, if x sub n is 0, well, that means it's that means if x sub n is 0, that means it's not free, right? And so in both of these systems, in the nth column, so both of these systems in the nth column, what does that mean? That contains in the nth column contains the leading entry of some row. Right? So let's say that again. So since x sub n is not a free variable, and so in the nth row, or excuse me, I'm sorry, I keep saying row, in the nth column contains the leading entry of some row. And since in an echelon matrix, right, in an echelon form matrix, any column that does not contain a leading entry is associated with a free variable. Okay, but now since in both of these systems, in the n minus 1 columns, they're all the same, right? We've already established that. Okay, so with B and C being equal, for the first n minus 1 columns, by the definition of a reduced echelon form, the leading entries in the nth column have to be in the same row. And both leading entries would have to be 1. And would have to be the only non-zero entries in that column. And if that's the case, then guess what? This system and this system has to be the same. So B would have to be equal to C. And that's the end of the proof. Have a great day.